talk to you about simultaneous equations, and simultaneous equations can be a little bit tricky. You have to do them in year 8, year 9, but they're an essential part of your arsenal as a mathematician, so you need to know how to do them and make sure that you get them right. So a few things to think about. We have two main techniques to work with that we use. One is called elimination, one is called substitution. So elimination relies on the idea that you would eliminate a variable so that it's no longer there, so that you have everything in terms of x or everything in terms of y. Substitution is when you take a variable and isolate it and then you plug it into the other equation, so that you isolate it and then you substitute it. A little bit like when you substitute a player in sports. So we're going to try and work through these. The main issue being that we don't know how to solve equations with two unknowns. We need to change it to equations with one thing that you don't know. So that we know how to solve. So that's why we have a bit of an issue when we have two variables, like you have x's and y's. So let's start with elimination. So I like to first label my equations. So I've labeled them 1 and 2. And I notice immediately that I have 3y's here and minus 6y's here. So if I was to multiply this line by 2, I would have 2x plus 6y equals minus 14. And that would be quite handy because 6y minus 6y could go away. So if I added those two equations together, that could go away. So I'm going to do that. I'm going to double the first line and I'm going to add it to the second line. So I'm going to do 2 times 1, so 2 times line 1, sorry, 2 times line 1, and add it to line 2. Now in doing that, this is what happens. So 2 times the first line gives me 2x plus 6y, and then I add it to line 2, so plus 5x minus 6y equals, and then I have to double the negative 7, so minus 14 plus 28. Okay, well that's not too bad. 2x's and 5x's, that's 7x's, and then 6y's minus 6y's, 0y's, which is the whole point. I've eliminated the y variable. And that's equal to negative 14 plus 28, which is positive 14. Super! I can divide by 7, so x equals 14 divided by 7, x is equal to 2. Okay, so I found my x variable, and now I can try and find my y variable. So what I'm going to do is I'm going to put this x value inside perhaps the first equation. So in equation 1, I can say that 2 plus 3y is equal to negative 7. I move the 2 to the other side. 3y is equal to minus 7 minus 2, so plus becomes minus. 3y equals negative 9. And then times becomes divide. Y equals minus 9 over 3. Y equals negative 3. So I know that my set of solutions, and I can write this with nice squiggly brackets, x, y, my solution set is equal to the pair of numbers 2, so I'm going to write that down, x equals 2 and y equals negative 3. Now those are my solutions and I'm quite happy with them. If I want to check them, I can plug them back in. 2 times, so 2 for the x value plus 3 times negative 3. 2 minus 3 is minus 7. I'm pretty sure that's correct. I could double check with equation 2 as well, but I'm not going to at this point in time. I'm going to focus on the second method, which is substitution. So I should find a way to isolate either the x or the y value. Now, it's pretty handy that x is equal to minus 3y minus 7. So I'm going to use that fact from equation 1. I'm going to move the minus 3y to the right. So I'm going to say x equals minus 3y minus 7. Okay, well that's great. I can use this value of x and plug it into equation 2. And then I'll have everything in terms of y and I'll be able to solve. So I say in equation 2. Again, I like to use colors and make sure that I explain what I'm doing so that my examiner knows that I'm on track. So 5 times minus 3y minus 7 minus 6y equals 28. So what just happened? I plugged in the x value as minus 3y minus 7. I substituted it in equation number 2. So now I'm going to be able to solve because everything is in terms of y. So 5 times minus 3y is minus 15y. 5 times negative 7 is minus 35. Minus 6y equals 28. So what's minus 15y minus 6y? That's minus 21y's. Minus 35 equals 28. If I move the 35 to the other side, it becomes plus 35. So minus 21y equals 28 plus 35, which is 63. So if I want to do this fast, I can do 28 plus 5 is 33, 33 plus 30 is 63, so minus 21y is 63, y equals 63 over minus 21. Now luckily enough, 21 times 3 is 63, so y equals negative 3. Following the same steps as I did before, I can say in equation 1, if I know the y value, I can say that x plus 3 times negative 3, so x minus 9 is equal to minus 7, and if I move it to the other side, x equals minus 7 plus 9, and minus 7 plus 9 is 2, so I find the same two values, x, y equals 2, negative 3. So of course I'm going to find the same solutions because mathematics is perfect. No, it's not perfect. It's just that with simple equations like these, mathematics works out. So you can have faith in the system. It's a system we created for sciences. And in this case, elimination works, substitution works. As long as you do it properly and you're confident with your steps, you should have no problems at all. So it doesn't matter which technique you use. Both techniques are always accessible to you. It's always possible to do elimination, it's always possible to do substitution, and it's always possible to solve using either of those techniques. So whichever one you feel more comfortable with, that's okay. Now, I hope this was useful to you today, and if you'd like to follow us, make sure that you come and find us on Instagram at hlmathemagic. Instagram is mathemagicmd, and on Facebook, facebook.com/hlmathemagic. So this was simultaneous equations. And remember, simultaneous equations don't have to be so hard as long as you know what you're doing. Thank you so much.